Okay, class, today we are doing section 8.2 on arithmetic sequences and series. So, arithmetic sequences have a pattern, and it's a pattern where there is a constant or a common difference between consecutive terms. So we say common or constant. And the difference is called the common difference, D. Okay, so we're going to use the letter D for the common difference. Okay, so the rule for an arithmetic sequence, you're going to have A1, which is your first term, D, which is your common difference, and then you're going to have the formula A sub n, so the nth term is the first term plus n minus 1 times D. Okay, your book uses a slightly different formula. It's equivalent. It's just written slightly different. You can use either one you want. This is one we're using. Okay, so tell whether the sequence is arithmetic, and if so, write the nth term. So we're going to look at, 5 is our first term, so that's my A1 term. We have the A2, 3, and 4 term. So we want to see if there's a common difference, or a constant difference. So from here to here, we added 6. From 11 to 17, we added 6. From 17 to 23, we added 6. So my common difference is D, and it's 6. If we kept subtracting 6, then the common difference would be minus 6. Okay, so since there is a common difference, that tells us that it is an arithmetic. Okay, so it is arithmetic, so we're going to write the rule for the nth term, and the nth term rule always follows this pattern. A sub n is A sub 1 plus n minus 1 quantity times D. Okay, so n is going to be the variable. It's like in linear equations when we did things with line, x was the variable. With sequences and series, n is the variable. Okay, so A sub n is the first term, A sub 1, which is 5, plus n minus 1 times the constant difference, D, which is 6. So I just plug in the two things, the 5 and the 6. And then we're just going to kind of write it in standard form, which would be kind of like the equation of a line. So A sub n is 5 plus, I'm going to distribute 6n minus 6, or A sub n is 6n minus 1. Okay, and just so that our notation is clear, A sub n, this is a little subscript n, but it's 6 times n. That's a big N. Okay, problem number 2. Let's see if it's arithmetic. Here we added 4, so it's looking arithmetic, but if we keep checking, we added 2, so it's not common. Okay, so there is no common difference, so it's not arithmetic. Okay, if it was arithmetic, it would be a common difference all the way through. The last term, 32 to 47, add 15. Up to 62, you have to add 15. Up to 17, add 15. That tells you D is 15. 32 is the first term, so that's my A1. So A sub n is 32 plus n minus 1 times D, which is 15. Write it in standard form. A sub n is 15 times n, and then 32 minus 15, doing a step in my head there, get 17. Okay, so this is arithmetic. So in section 8.2, it's about arithmetic sequences, which is always going to follow the pattern where you keep adding or subtracting something, and all arithmetic sequences have a pattern like this. You don't have to just stare at it until you come up with a formula like you did in section 8.1. Okay, so here we're going to find the nth term, given that A8 is 50 and D is 0.25. So we're going to use A sub n is A1 plus n minus 1 times D. Okay, so this really should tell you the nth term of the arithmetic sequence. Okay, but given that it says D equals something, that tells you that it is an arithmetic sequence. But you do need to know that it's an arithmetic sequence to use the formula for an arithmetic sequence. Okay, so with this first term, A8 equals 50, this is my n, right? That's my a sub n. So when n equals 8, my a sub n is 50. Okay, so my 8th term is 50. I'm going to use that. So my a sub n term is 50 equals a1. Well, I don't know what that is. I'm going to leave it as a variable, plus n. Well, when I get 50 for my term, the term number, n, is 8 minus 1 times d, which is 0.25. Okay, so first of all, I don't like decimals, so I'm going to just write 0.25 as a fraction. You, of course, have a calculator, and you will have a calculator, so you can write it as 0.25. And so here I'm just going to solve for a1. So I get 50 plus 50 equals a1 plus 7 over 4. So I'm going to solve for a1, and I get 48.25. Okay, so now I have a1, and now I have d, so I'm going to take those two things and plug it into a sub n is a1 plus n minus 1 times d. So my a sub n is a1, 48.25, plus n minus 1 times d, which is 0.25. Distribute, write it in standard form, 0.25n plus 48. And that is my nth term rule. So this one differed because I wasn't given the first term. I had to find it using the 8th term. So the 8th term was 50, and I plug in the 8 for it being the 8th term. Okay, move on to the next problem. Here it says two terms of the arithmetic sequence are these two. So we're going to do the same sort of thing. We're going to write up a system of equations. So I have a sub n is a1 plus n minus 1 times d. So my a sub n with this first given information is 10 is a1 plus n. When I plug in 10, that was my 5th term, times d. I don't know that. Two unknowns. So if you have two unknowns, you need two equations. So this first bit of information gave me that, and this is my second bit of information to give me a second equation. So I have 110 is a1 plus the n that goes with this is the 30th term, 30 minus 1d. Okay, so from that, I'm just going to simplify. 5 minus 1 is 4. 30 minus 1 is 29. So I have two equations, two unknowns. You can use various methods to solve this. I'm going to use elimination. So I'm going to multiply this first term by negative. So it becomes negative 110, negative a1, negative 29. So I have 10 minus 110 is negative 100. Those cancel away, and I have 4d minus 29d is minus 25d. Solve for d, and you get 4. Okay, so that's one of the things I needed to find d. Now I need to plug it in to find my other unknown, which is a1. So I'm going to plug d into here. Okay, so I have 10 is a1 plus 4 times d, which is 4, or a1 is I get 16, bring it to the other side, negative 6. So I have my two bits of information, so now I can plug it into my equation for the arithmetic sequence. A sub n is a1, negative 6 plus n minus 1 times d, which was 4. Distribute, a sub n is 4n minus 10. And that is the nth term rule. And now I'm going to find the value of n for which a sub n is negative 2. So my a sub n is negative 2, so I'm going to plug that in. Negative 2 is 4n minus 10. I'm going to solve for n, bring 10 to the other side, and I get n equals 2, which tells me the second term is negative 2. Okay, let's go ahead and move on to the next problem, number 4, and before we get to that, we're going to talk about series. So it says find the sum in an arithmetic series. So a series is when you add up the sequence, and in order to do that, there is a formula. So to find so many n terms, like the first 100 terms, so n would be 100, so it'd be the 100 terms divided by 2, and you add the first and the last term. Okay, so this only works for sum of arithmetic sequences. Okay, in 8-1 we had a bunch of different other sequences. This is only for arithmetic sequences. Okay, so we're going to find the partial sum. So here we're going to find the first 25 terms. See, this series goes on to infinity, but we want to find the partial sum, which is the first 25 terms. So here it tells me my n is 25. So 20 is my first term. That's my a1. In order to find S25, that's the sum of the first 25 terms. It's the number of terms you're adding up, which is 25 over 2, times the first term a1, which is 20, plus a sub n. We need to know what a sub n is, where n is 25. So we need to find a sub 25. So in order to find a sub 25, what we have to do first is write the rule for the nth term of this sequence. So this sequence is arithmetic. You can look at it because you keep subtracting 2. So with that information, since you know the d, we're subtracting 2, your a1 is 20. We can write the nth term rule. A sub n is a1 plus n minus 1 times d. So a sub n is 20 plus n minus 1 times negative 2, because we're subtracting 2. Or a sub n term is negative 2n plus 22. So this is the nth term rule for the series here, right? The sequence that went with that. And we ultimately want to use this formula to find the first 25 terms. So in order to do that, we have to find the 25th term. So we have the nth term rule, so we can just plug it in. A sub 25, plug in n equals 25, negative 2 times 25 plus 22, or a sub 25 is negative 50 plus 22, which is negative 28. So I'm going to plug that in. The last term is negative 28. And I'm going to go ahead and just simplify this. This is negative 8. And then, so s of 25 is 25 over 2 times negative 8. Simplify that down. S of 25 is negative 100. So what that means, if I add up the first 25 terms in this long series of numbers, I get negative 100. You could sit there, 20 plus 18 plus 16 plus 14 plus 12 plus blah blah blah, all the way down till you get to the 25th term, which is negative 28, and sit there with the calculator, add them all up, and get negative 100. That would be tedious. The point would be to use the formulas to achieve your answer. So you want to make sure you do use your formulas. Okay. So the last problem we have is to find the partial sum. So for this partial sum, we want to start by plugging in 51 and go all the way up to 100. Okay, so if we write this out, remember this means the sum of that pattern. So first plug in 51. So it's 7 times 51. Plus you keep incrementing. 7 times 52. Plus 7 times 53. And I'm not going to write it all the way out, but it'd be dot, 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 plus 7 all the way up to 100. Okay, where this is your last term, this is your A100, and this is your first term, A51, essentially. Okay, your first term. Okay, so this is the first term we're adding up, this is the last term we're adding up. So this works. The first term you're adding up, the last term you're adding up, multiply the number of terms you're adding up, and divide by 2. So we're going to use the same formula, we're just modifying it slightly. So S, how many terms are we adding up? From 51 to 100 is 50 terms. Count on your fingers from 1 to 10 is 10 terms, not 0 to 10, that would be 11 terms. So we're adding up 50 terms, S50, so it's 7 n over 2, we're adding up 50 terms, dividing by 2. The first term is 7 times 51, plus the last term, 7 times 100. Put that into your calculator, you get 26425. Okay, I will talk more about this example in the class, and I hope you have a great evening.